Hi, how's everybody doing today? Jeff Zwarenk here, and just looking forward to our time to kind of talk about what's going on. Appreciate the opportunity or the time you have taken out to join me today. Just looking forward to our time. It's weird, I got to say, being out here. I live in Southern California, grew up in the Midwest, and one of the things that I have been fascinated with or enjoyed a lot is sports. And so I remember back actually when I was in sixth grade, my sixth grade teacher would bring in the TV during the World Series, actually during the playoffs, because the Royals would typically make the playoffs. And right around 1980 was the first year they made it to the World Series. I remember being disappointed when they only got, or they lost the World Series, but a few years later they managed to win. And in this time off where we've been home a lot, I've gotten to enjoy a lot of Chiefs highlights this year because it's been a good year for the Chiefs. Really enjoyed, sorry for you Texans fans, really enjoyed that first round playoff game for us where we got to play the Texans. But one of the odd parts about that, and kind of what I want to talk about today, is what happened shortly after we moved to California. See, I grew up in the Midwest. My wife grew up in the Midwest. We met at Iowa State University, got married there after I graduated. I was in graduate school for about 6 years after that, taught for a year in Iowa, and then God brought me out to California with my job. And so we moved out to Moreno Valley, and it's hot in Moreno Valley. In the summers, it gets well up over 100 degrees typically. And so some friends of ours had invited us out on a kind of neat excursion. We were going to go up to a place called Forest Falls. And as I've looked back on what happened in our trip out to Forest Falls, it just reminds me a lot of how God works in creation. And I just kind of want to articulate some of that, what I see there, because I enjoyed that day. It was a very fascinating day. And like I said, it just reminds me of how God works in creation. One of the things, so just to kind of set the stage, as you head outside or head out from Moreno Valley, you go up 38, heading up towards Big Bear. And after you've gone a number of miles, there's this turnoff where you start heading off to Forest Falls. And it's about 3 miles back up into this valley. And as you start the turnoff, it just looks like a road going off through the mountains. And the further you go up this road, the valley kind of narrows, the walls get higher. And up at the top, there's some nice falls, there's a campground. But as you get in, the road kind of runs along the south side of the valley, and the valley gets narrower and narrower, and the walls get steeper and steeper. And there's this little stream running down through the valley. It's just a gorgeous place. And as you're driving up, kind of the destination, if you will, was this old campground. And it's they've since stopped camping there, and people can picnic there. And we got up there that day, and the campground was just, or the picnic area was just full of people, because the reason, or what you get to see when you're up there, are the falls. And there's just a little bit of hike. You go across the creek, hike around maybe less than a quarter of a mile, and you get this beautiful view of this just cascading stream flowing down the mountain. Just gorgeous time, cooler temperatures, just enjoying the time with our friends. Now, as we were going up there, we were having lunch, and we'd run into a number of delays, but right about the time we were getting done with lunch, getting ready to head over into the falls, my friend and I were looking up at the sky, and there was just this big, dark storm cloud. And in the span of about 30 minutes, 2.5 inches of rain fell. Now, imagine, if you will, what would happen if you're in this narrow valley and 2.5 inches of rain fall over this valley that's just funneling all the water down into this stream. Well, that's the scenario in which we found ourselves that day. And as we looked at what happened and all the events of the day, it was just a reminder of how God works in creation. And what I see is kind of 3 points that I just want to talk about and articulate today. First, that as we look at creation, I just am in awe and appreciation of God's power. You see, as we were in that environment, it rained for 30 or so minutes. My friend and I were talking. It's like, oh yeah, that's not going to be a big deal. We'll just kind of let it blow over. And it just rained and it rained and it rained. And there were about 9 of us there. And so, or 8 of us there. And we were getting about ready to head back down. And we said, no, we'll kind of wait it out. And after we got done, the rain had passed and everything had kind of settled. We got to go out and start exploring. And what had happened in that half hour's worth of rain, where we got the 2.5 inches of rainfall across this region, just a torrent of water came rushing down the creek. And you go back and you look at pictures later, and I don't know who the person is, but for reference there, this water just came and stripped bark off of trees. You can see they're probably 8 feet high. It had just taken all the bark off. And this isn't even in the creek bed. This is just kind of off to the side of the stream, kind of up even over the hill. And as we walked around and looked, we saw that there were 4, 5, 6 foot boulders pushed up into houses. And it was just kind of a marvelous, awesome thing to see these huge boulders, this awesome, amazing power of the water as it just kind of tore down through this valley. And I can kind of say that because the flood did a lot of damage to structures. It did very little human damage, and so there's part of that not marveling in the damage that it does to people, but just realizing there's a lot of power here, and just being kind of fascinated by that. And as I've looked at creation, I find that this is not an uncommon thing. We see, as we look and study how the universe works, there's just a lot of things that have pretty awesome power. A few years back, I was able to take a trip up to Washington State with my family. Now, one of the signature features of Washington State is a place called Mount St. Helens, which here is a picture of Mount St. Helens before it erupted in 1980. And it's this mountain that's thousands of feet high. It's snow-capped volcanic mountain. And in May, I think it was May of 1980, there was just enormous eruption. And if you compare the picture before, as you look right outside the window behind it and see the picture after, you can see that about a half mile of the top of the mountain was just blown off. There was more than half a cubic mile of material that was just blown off of the top of the mountain. And it kind of went cascading down the side of the mountain. It actually, if you kind of look down in there, you can see this lake down there. It actually pushed that lake up further. Just an incredible, enormous, powerful event. And one of the things that I find interesting is that as we look at this, we can actually talk about and understand the processes that result in flash floods and result in volcanic eruptions. We kind of understand them, and that kind of gives us this sense that in some way we're in control of them. But as I look and investigate more deeply, if you compare what the top of the mountain was with what it looks like now, you'll just see that you might be able to comprehend how humanity could actually remove that much of a mountain. But this is a really relatively tame event considering the types of events that occur throughout creation. In fact, if you look out a little deeper, you're looking at the planet Jupiter, and you'll notice there are these little brown spots streaking across kind of the bottom of the planet there. And those brown spots are from a asteroid that collided, or a comet that collided with Jupiter back in 1994. I remember this because I was in graduate school, and this comet had made a pass around Jupiter and had been stripped apart. It was coming through in, I think, 26 different pieces. Those pieces range from the size of a football field or so up to a few miles across. And each of these impacts, to give you a scale for the size, you could fit the Earth in each of those impacts. So these are enormous impact events. And the top of Jupiter is all clouds, so it just kind of makes a damaging environment there. But when we look at the amount of energy released in a number of these impacts, some of the larger ones, or even the smallest of the impacts, those impacts would release more energy than the simultaneous detonation of the entire nuclear arsenal of the world. Now, atomic bombs, as they go off, especially the thermonuclear bombs, they're just incredibly powerful. And there are thousands of these bombs that various countries in the world have. And if you can imagine detonating all of those at once, that's still 10 times less powerful than even the smallest of these asteroids hitting into the planet Jupiter. And what's interesting about that is you look throughout the course of Earth's history, and we find evidence of these sorts of impacts regularly hitting planet Earth. For example, one of them, there's articles that show that we have probably once or twice in Earth's history, Earth has been hit with a 30-mile asteroid, an asteroid that's 30 miles across. And so there's various folks that said, all right, what would happen in the aftermath of an event like that? Well, we can kind of count. So you say, all right, well, we kind of know how big it would be, roughly what its density, what its velocity would be coming in. And the first thing, we're just going to watch this from 1,000 miles away. So if you're in Colorado, you could imagine this hitting Los Angeles. If you're in Los Angeles, you could imagine this hitting in Denver. That's roughly 1,000 miles. And this is what happens. First, after everything's all said and done, it's going to leave a crater that's 235 miles in diameter. Now, if you go look at most of the states scattered throughout the Midwest, they're about 200 miles across. So this crater would be larger than most of Kansas, Iowa, Nebraska, those sorts of states. Just wait a little bit, and after about 30 seconds, you see this fireball growing up over the horizon. And it will be 40 times larger than the sun and 200 times hotter than the sun, and it'll last for about 2 hours. And you say, all right, well, what might happen in that 2 hours? Well, all the clothing is going to ignite, any sort of newspaper burn, as does all plywood, grass, and deciduous trees. So you're sitting out there in the park reading your paper. Your paper is going to be incinerated. Your clothes are going to be burned off. The bench in which you're sitting is going to be burnt up, and all the trees around you are just going to be gone. Pretty spectacular event, but that's not all. Wait about 5.5 minutes after the impact, the earthquake from the impact will finally roll through. Now, it's going to be a magnitude 11 earthquake near the impact crater, but as it propagates 1,000 miles away, you're still going to feel it in quite significant ways. If you wait another 5.5 minutes, you get out to 11 minutes, and you start now experiencing this fine dusting of ejecta that's going to cover you in a total thickness of almost 10 feet. And if you keep waiting, eventually, about an hour and a half after the impact, there's an air blast that's going to arrive with a sound intensity of about 116 decibels. That's on the order of what a jet engine on an airplane taking off if you're standing out on the tarmac with no sound protection for your ears. That's about that sort of thing, same sort of intensity. And all the wood and multi-story buildings, they're just going to get knocked over. Office buildings are going to be distorted, and then they're going to probably collapse afterwards. Highway bridges are going to collapse. Glass is going to be shattered. Cars and trucks are displaced and distorted. And any of the trees that are left over, 90% of them are going to be blown down and all the branches stripped off. Now, why do I mention this? Because as I look out, there's kind of two fascinating things. One is that some scientists are speculating that an impact like this might have been what started subduction, which is part of the tectonic plate movement that allows earthquakes and the earth to build mountains and volcanoes and all that other stuff that goes on. So it's actually kind of critical for life to have this subduction process going. But it also is just a reminder that though we can go out and understand how things in the universe work, our universe is not a very tame place. There are some incredibly powerful events that go on that we live in the midst of, and we live in an environment that is conducive for us to understand and enjoy them, even in the midst of these very dangerous, dramatic, spectacular, awesome events. So not only do I look at that day as we were there in Forest Falls, and I just appreciate the power that God exhibits in his creation, I also began to understand God's design. Because as I was looking at what was going on that day, I'm going to give you a little more backstory. See, we decided to go while we were in church that morning. And as we got up, they invited us to go. And as we said, oh yeah, we're going to go, we'll go back to our house and get ready. And as we got to our house, realized that we had committed to taking food over to some friends. So we called our friends and said, hey, we've got to take some food over. So we made some food, made some chili, and took it over. And that took a long time to do that. And as we were driving up there, we were driving in two separate cars, and my friend's car actually overheated. And as it overheated, that delayed us getting there. So I had to go back down and bring him up there. And so eventually, as we got up there, we had our food, we were eating, we'd gotten all done. We were about ready to head over to the falls when it started raining. And as it was raining and pouring down, somewhere in the midst of that 30-minute rainfall, our friend said, why don't we just get in your car and go? So we were going to cram all 8 of us into my little Ford Escort station wagon, drive back down to our other car and head out. Now, we found out shortly after that we wouldn't be able to drive, because as we were going to go down, the one road in and out of here was covered 6 to 8 foot deep in rocks, boulders, and debris. And had we left right in the middle of that, we would have been right where the debris happened. But as it was, we were late enough getting there that we didn't actually get over to the falls before everything had started. We didn't end up driving down the road. And so we were in the midst of danger, but we were never in danger. And again, as I look out at creation, I see that that's the way God has operated on planet Earth. That there's a purpose for what's going on here. And let me explain what I mean there. Because in the midst of all of these things that come down and crash into the earth, and volcanoes erupting, and earthquakes happening, and tsunamis occurring, in the midst of all of these things, Earth has this capacity to host an abundant and diverse array of life, unlike anything we can see anywhere else in our solar system, and likely out in the universe. Let me explain how that plays out. So we live on the Earth, and when the Earth first formed, it was just covered in water. There were no planets. In fact, the oceans would have been very green because they were very iron rich and there was no oxygen in the atmosphere. And over the course of the last 4.5 billion years, there have been times where the amount of continents have grown. There was an episode a little bit after 1 billion years after the Earth was old, a little bit before 2 billion years, right around 2 and 3 billion years. There are these episodes where the number of continents grows. Now, why that's important is that there's another process that's going on, is that as the Earth is growing older, the amount of gases in the atmosphere are changing. And there was a very significant change that happened about 2 to 2.5 billion years ago. Like I said, before that, there's virtually no oxygen in the atmosphere. And something changed such that oxygen could begin accumulating in the atmosphere. And as free oxygen began accumulating in the atmosphere, it reacted with all the methane that was in the atmosphere. Now, methane is a very potent greenhouse gas. And so it's going to keep the planet very warm while the sun was much cooler. Now, as the oxygen goes up, the oxygen is going to react with the methane and produce water and carbon dioxide. Now, both water and carbon dioxide are good greenhouse gases, but not nearly as efficient greenhouse gases as methane is. And so what the reduction of all the methane is going to do is going to cool the Earth down, and it's going to drive the Earth into a great glaciation. And if you go look in Antarctica, there are just places where, as far as you can see, all you see are these big ice sheets. And scientists find evidence on the Earth that the Earth was likely covered entirely in glaciers. Now, it wouldn't have looked like this because this was 2.5 billion years ago, and the continents wouldn't have been in the same place. But we do see evidence for this mass glaciation. Now, what happens in the process of that is that ice reflects sunlight more. And so as more and more glaciers form, it's going to reflect all the sunlight back out into space. And that's going to cause the globe to cool even further. Unless something else goes on, the Earth is just going to be frozen and never be habitable. Except that because continents are being formed and volcanoes are erupting undersea, and that process of continent formation and volcanic eruption and tectonic activity that's going on is going to release an enormous amount of greenhouse gases, particularly methane and carbon dioxide and water vapor. It's going to spray that up into the atmosphere, and that's going to heat the planet up and melt and actually bring the Earth out of this ice age. Now, imagine if humanity had arrived 2.5 billion years earlier. Humanity would have been in this environment right when the globe was becoming inhospitable to humanity. But God was working to prepare Earth, because Earth, for humanity to be here, Earth has got to have an abundance of planets, or abundance of continents, because that's where 60% of all the advanced life on the Earth lives. It's got to have an abundance of oxygen, because that's the mechanism by which large body animals can exist. And so those changes have to happen, but they do so in a way, they could have done so in a way that would have prevented the Earth from being habitable. But it looks like everything was coordinated. So as the sun was getting brighter, and as the oxygen was increasing, and the continents were all working together, and the different kinds of life that were there, all of that worked together to make sure that even though Earth came close to being uninhabitable, all of those processes worked to make sure that Earth could maintain its habitability as God continued to work to make sure that we, humanity, could eventually be here. And so I see evidence of God's purpose in creation, not only in what was going on that day, but also in just how the Earth works. And we kind of say, okay, well, tectonic activity, that's just going to happen anywhere. That any planet's going to have that. Well, it turns out as we look at Earth, Earth has a few things that are particularly relevant for the way plate tectonics happens. Because in order to have plate tectonics, you need to have two things. One is there's got to be some rigid plates that can slide around, and then there's got to be a kind of fluid region underneath where the plates can slide. And so that some can go under, they can go on top, build mountains, volcanoes, and all that goes on. Well, if you look at how soluble water is as you go down in the Earth, typically we think of water dissolving stuff, but as you go deep in the Earth, water actually dissolves into the rocks. What you'll notice in that graph there on the right is as you go down about 100, somewhere around 150 kilometers, the solubility of water decreases. What that means is that not as much water can be packed into the rocks. And as a result, that water will come out, it will decrease the melting point, and given the kinds of chemical minerals and elements that are in that area, there will be a lot of melt. It will actually pull water out of the region above and make more melt below. And what that does is makes more rigid plates on the top that are not very thick. 100 kilometers is not particularly thick for plates. And it makes a malleable region underneath where the plates can flow around. And so if this solubility happened much deeper, the plates would be too thick and you wouldn't get tectonic activity, or everything would be incredibly violent when it happened. If it were too thin, the tectonic activity would be happening all over the planet at all the time. But it happens at just the right depth that there's enough tectonic activity that allows the Earth to stay habitable, but not so much to disrupt the life that's here. And again, on a larger planet, that region is going to be in a different place. And on larger planets, it's going to be too much tectonic activity. On smaller planets, there's not going to be enough. And in fact, as we look at the planets throughout our solar system, we see just that phenomenon at play. So as I'm thinking back on that day, I appreciate God's power. I see that God's design in creation, but I also see that God had a plan. Now, to finish out the story, so we left on Sunday morning. We were late getting up because the car was delayed. The car overheated. We had to drop off the food. As we got up to the place where we were going to picnic, all of the picnic tables were full. So there was no place to stay. So we circled around 2 or 3 times, and eventually we spotted a picnic table. And there were 3 picnic tables, and only 2 parking spaces. So I was going to park the car, let everybody out, go down and park in the parking lot. And so we got out, unloaded everybody. And as I got back in the car to drive down, one of the other people who were there in the 2 parking spaces said, you know what, just park your car behind ours. We're not going anywhere for a while. So great. So I left my car there. We got out. We enjoyed our lunch. It was an O lunch. We had Cheetos and Fritos and Oreos, and we had hot dogs. And we finally got everything cooked, and we were about ready to head over to the falls. And that's right when the rain started. Now, we sat and waited out the rain. Had we left in the middle of the rain, we would have been in the road right when it got washed out. Had we been there any earlier, we'd have been over at the falls when the flash flood happened, and we probably would have had some of us would have not made it through there. We were moments from danger, but never in danger. And in fact, even where my car was, where I was going to park my car, that whole area of the parking lot was just washed away. Now, in that day, for whatever reason, God had a plan to protect my friends and my family from any sort of harm. And I'm not going to say that God is always there to keep us away from harm, but in that particular day, that was part of God's plan. And again, it's just as I look out at creation, I see that God has a plan for what he's doing in creation. So here's a map of the Earth, and it's probably not one that you've seen very often because it's not about where the land is. It's all about the elevation. So you see those blue regions, the dark blue regions, those are where the water is. But even in the water, you can see high places underneath mid-ocean ridges. You can see on the continents, there's very high elevation, there's very low elevation, there's reds and greens. There's a lot of detail in this map. And all of this results from tectonic activity and the plant life and how glaciers have happened and how asteroids and comets, all of that contributes to how the Earth looks today. And I say that because I want to compare this picture with the same picture taken of Mars. Now, Mars is one of these planets we think, oh yeah, life could be there. That's a good place to go. But see this picture from Earth and compare that with the picture from Mars. Same scales, but they look very different. You know, there are some low regions, there are some high regions, but if you look at this picture from Mars, it's kind of like a low resolution version. And if we look back at Earth, it's just much higher resolution. And if you want to have a planet where organisms like us could be, you've got to have the tectonic activity and the plates spreading and the volcanic activity and the atmosphere and all of these things going on. All of these features being produced are what allows Earth to host the life that it does. And when we look out on Mars, what we see are a few high places where volcanoes grow very large. In fact, 4 of the largest volcanoes in the solar system are on Mars. You see the surface is just pocked with asteroid impacts. That's because there's no weathering, there's no processes that refresh the ground and bring new nutrients to the surface and allow life to live there. There's no water on the surface of Mars. And so we see when we compare Mars, and if we do the same thing with Venus, we see that Earth, God had a plan for Earth. In fact, we hear that in Isaiah. It says, the God who created the heavens and the earth and did not form it a wasteland, but created it to be inhabited. That God had a plan for Earth. And, we see that evidence of the plan. In fact, when we go look at those asteroid impacts, some of the most abundant resources of metals and other things that are important for civilization happen in areas where we dig mines where these impacts have happened, because they concentrate metals that would be very difficult to find other places on the Earth. And so we see of God's purpose as we look at creation. So as we went through that day, just to kind of wrap up the story of what happened up at Forest Falls is the road was closed and we were stuck up there for the night. There was no way to dig it out. And so our friends and ours, we were walking down the hill. There was a restaurant that was undergoing a remodel, and they said, hey, everybody could stay there. And as we were walking down, my friend, being a rather gregarious person, struck up a conversation with some folks who had a house up there. And they saw that we had a baby there, and they said, you know what, hey, why don't you guys come and sleep in our basement? They just had a party for their granddaughter the day before, so hey, the party's here. And we got in and we were getting in the basement, getting ready to hang out there. And eventually they came down and said, why don't you guys come up and join us? We've got some watermelon. Come eat some watermelon with us. So we cut up the watermelon and enjoyed a good watermelon that day. And as we talked with them for a while, they said, you know what, we've got a couple of rooms upstairs. Each one has a king bed. Why don't each of your families take one of those? And so in the midst of this disruptive, incredibly bizarre and kind of chaotic day, we ended up having a nice meal, hanging out with some newfound friends, having a nice place to sleep, and just enjoying the party. Now, again, I'm not going to say that God always works that way, because as you read through Scripture, you see that there are some very disruptive and destructive things that happen, and that God's in control of all that and using that to fulfill his purpose. But for this day, as we followed and did what was wise and prudent and tried to follow him, God really just took care of us. And I see that as we look throughout creation as well, that God really does take care of us. And so I'm gonna take a few minutes before I wrap up here, and we're just gonna throw it open for some questions. I see some have come up on our Q&A board, so I got a question from Robert. It says, how much did photosynthesis play in getting plate tectonics going? Did the photosynthetic remains contribute to the lubrication of the geological fault lines? Well, I know that photosynthesis plays a critical role in generating the oxygen in the atmosphere. That's what produces the bulk of the oxygen. So obviously it plays a role there. I do know also that we tend to think of life as just living in the environment as opposed to shaping the environment. So not only did the bacteria through photosynthesis, create a bunch of oxygen in the atmosphere, but they've also worn down the rock, and they stir the oceans. They do a lot of things to affect the environment in which we live. And so I do know that the types of life that exist, Earth could support different kinds of life throughout its history, but those life have also changed the face of the planet. And so I'm not entirely sure whether the photosynthetic remains of life actually lubricate the faults. I think water plays a key role in that. I know where water ceases from a planet, plate tectonic activity ceases very quickly after that. But what we see is, rather than life just living on a planet and responding to what's there, on any planet, or especially on Earth, we see that there are atmospheric processes that affect how habitable life is on Earth, or how habitable Earth is. There are astronomical processes, asteroid impacts, and the amount of luminosity from the sun that impact how habitable the Earth is. There are geological processes, tectonic activity and such, that affect it. And there are also biological processes. And it's rather than one of those happening and the others adjusted, it's when you look at it, it's like there's this concert or this symphony going on, and all of them are working together to produce a planet that is habitable. That, to me, is a signature or a sign that there is a creator who's fashioned this planet for a purpose and is orchestrating things to accomplish a goal. Question from Angelica. It says, is there tectonic activity in any other planets besides Earth? And the answer to that is yes. So when we look at Mars, for example, we see that there are these very large volcanoes, and those volcanoes are part of the tectonic activity that's going on. When we look at Venus, we see that the surface of Venus is fairly new, which means that there's volcanic activity, tectonic activity that has resurfaced the planet fairly recently. And so, yes, we do see tectonic activity on other planets. What distinguishes what we see on Venus and what we see on Mars from what we see on Earth is that on Venus and Mars, it's very slow tectonic activity. And it's kind of like the heat from inside the planet builds up, because the plates don't move around much. And when it happens, it's kind of catastrophic. It just resurfaces the whole planet, or you get these massive volcanoes. Whereas on Earth, there's enough tectonic activity to build up mountains and allow volcanoes and subduct crust and all that sort of stuff. But it's not so much to catastrophically resurface what's going on. And so, yes, we do see tectonic activity on other planets, but what we see is it's like it's a designed amount of tectonic activity that allows, or that causes Earth to become more and more habitable over time. Question from Michael. When and how did God create life 2.5 billion years ago? What scriptures apply? Honestly, if I look at the scripture, I don't find much in scripture that talks about life 2.5 billion years ago, because most of human history, we wouldn't know anything about the kind of life that exists then. I do find, scripturally talking, I do find one interesting passage as you look through Genesis 1. It says, in the beginning, God created the heavens and the earth was formless and void, and darkness was over the surface of the deep, and the Spirit of God was hovering over the surface of the waters. Now, in that formless and void, there's a picture, a physical picture, but there's also this connotation of Earth being hostile to life. And when we look at early Earth's history, it's being bombarded with large asteroids. The moon, the event that formed the moon was probably something, or the size of a planet that hit the Earth. But things that would sterilize the top couple of miles of the Earth regularly hit the Earth. And so it has that description of the early Earth being hostile to life is very apt, both scripturally and scientifically. But the reason why I bring that up is to point out that word for what the Spirit is doing. And the Spirit of God was hovering over the surface of the waters. The only other place that's used in scripture is, I think it's in Isaiah, but where it's talking about an eagle hovering over its nest, nurturing the young that are there. And so that may have this implication that God introduced life onto Earth very early and was protecting it in the midst of a hostile environment. But you got to realize that for most of Earth's history, since it was formed, Well, complex life arrived on Earth about 550 million years ago. So for about 4 billion years, the most complex life were these single-celled organisms. And those, I just don't find those are going to be mentioned in Scripture. As for how did God do that, I really don't know. It may be that he just poofed them right there into existence. It may be that he orchestrated all of these processes that we can understand, but he orchestrated them in such an unusual, bizarre way to bring about that first life. I don't know. That's part of what I find scientifically and theologically so interesting about this question, is that we can go in and actually ask, how does life work? How did it come about? What can we do that helps us to understand that? And as my colleague Fuzz Rana, who's written a lot about this, has said, that the more we look at that, the more we invest effort into designing new organisms and fabricating DNA from scratch and doing all of these things, we see that life comes from incredibly well orchestrated, intelligent activity, whether we're doing that in the lab or whether God's doing that on the early earth. Both of them point to a mind behind the life that's there. Question from John. It says, one of the arguments against the fine tuning is that the constants of nature can be changed more than reported if you allow more than one constant to be changed at the same time. What is your response to that? And I would say, yes, that is correct, that they're quantifying the fine tuning of the constants of the universe is a difficult thing to do for a number of reasons. One is that we really don't know whether they can be changed or not. We can offer scenarios where we do the calculations and say what would happen if, but it's very difficult. We don't know whether they can actually be changed because we have one universe and we don't know whether that's the only way it could be or whether there are multiple ways. And there are scientific arguments on either side of that, that there's no data that distinguishes from either one of those scenarios. Now, we do have some models that say, all right, this constants could change quite a bit. And the more we tend to unify the laws of physics, it seems like more and more constants come in, or there's more and more flexibility in what things could be. So there's a really difficult process or difficult task of trying to quantify the fine tuning there. Now, what we can do though is say, all right, so let's hold everything else constant and let's change one. For example, let's change the mass of the quarks. And if we can show that if we change the mass of the up or down quark by somewhere between 1 to 4%, you get nothing like water, and water being so critical to life, you say, all right, well, that would make it very difficult to have a habitable planet or a universe that can have habitable planets. But that doesn't get at the question that John is asking. We can change multiple features at the same time. And in fact, I can point to articles in the scientific literature where people say, all right, let's remove the weak force. So that's changing one set of constants. And then they say, all right, what would I have to do to these other constants? Could I adjust these other constants to get a universe that might be habitable? And you can kind of rearrange them and find that, yeah, you can find a different configuration that looks like it might be habitable. Now, you can ask the question, is it habitable? Because if you don't have the weak force, you don't have decay. And so how do you get energy, heat energy inside a planet? So there's lots of, that question becomes complicated very quickly. But that doesn't change a characteristic of that, is that we can ask the question, we see Earth has this set of characteristics, and changing any one of those a little bit leads to something that doesn't appear habitable. I can also navigate and change a whole bunch of them and end up in another place where I've got something that's habitable. The key question in that, and it's a difficult question to answer, we might not be able to, is of all that space that's out there, how much of that space is occupied by habitable regions? Is it that there's this vast ocean of uninhabitable stuff and a few islands that pop up that are habitable? And if that's the case, then things still look fine-tuned. Or is it the case that there's this vast space out there and a whole lot of it could be habitable? And we just don't have a good answer to that right now. As of right now, it looks like that there's a lot of space out there and a lot of it is uninhabitable. Or a lot of the arrangements of the constants of physics would be uninhabitable. So I do think there's there's a fine tuning or a design argument you can develop there. But you do have to recognize there are these limitations when you're trying to quantify it, especially when it comes to talking about the constants of physics, because there are just some scientific issues that we don't know what sort of variability is there, what sort of range it is, or even, while we can study it, we really don't know what would come about afterwards, because there's a lot of things about life that are unusual. The properties of water are very unusual. It's not entirely clear we would have predicted the properties of water if we didn't know water existed. So we just have to be a little careful there. Question from Ken Wolgamuth says, I wanted to ask Jeff about the moon moving slowly away from the Earth, and some claim that this limits how old the Earth can be. What is this history? It said you may have an answer in a blog post. I know we've written about that on our website, but so the idea, if I understand Ken's question correctly, is the scientific idea out there of how we got our moon, or the best explanation, is that during the process of formation, Earth is orbiting around the sun, and it's got a companion body that's orbiting probably in the similar orbit. And at some point in time, those two things collide, and they collide in a relatively fine-tuned way, or a relatively unusual way, or rare way, such that enough material is thrown off into space that the Earth can reform, and then you get a large moon, because Earth's moon is unusual compared to every other moon we see in our solar system. Earth's moon is not the largest, but compared to its host body, it is by far the largest. And that has interesting implications for the stability of Earth's rotation axis and other things like that. So early in Earth's history, this collider event happened, the moon formed, and as the moon orbits around the Earth, it actually extracts energy, and it drifts away, it slowly migrates away from the Earth, just because of the orbital dynamics. And so some have gone and said, all right, well, we can map out what that is and say the Earth, or the moon, to get to its current location, given its speed, would only take 1.5 billion years to get there. And you're saying the Earth's 4.5 billion years old, so that doesn't explain things. To my best knowledge, when you actually go in and include the tidal forces and the deformability of the Earth and the moon, and the fact that there's water on the surface, and you work through all those calculations, you find that the moon is actually at the right location. All those calculations work together, and they match the location where the moon is, even if I could find other ways of doing the calculation that would get other places. So we can find, given a reasonable set of parameters for how the Earth behaves and how the moon behaves and how the gravitational interaction between them works, we find that there's a perfectly consistent explanation where a large object hit the Earth, spun off this material, and the moon is slowly moving away from the Earth. That story all is coherent. And so if some who would say that the Earth cannot be billions of years old want to use that, they have to show how, given a reasonable set of models, how these reasonable set of models either don't work, or they have to show how it can't be 4.5 billion years old. And no scientific work that I have seen does that in any sort of conclusive way, or even reasonable way. So we have a question from Maria. In fact, I actually just read something else in a scientific article, that they were able to study certain kinds of organisms and show that the Earth's rotation rate was actually faster in the past. And why that's interesting is because as the moon moves further and further away, the Earth's rotation rate slows down. And so we see evidence that the Earth's rotation rate was faster in the past. That provides evidence for this moon collider impact theory of how, or giant impact hypothesis of how we got the moon. So I know people pick at that, but if somebody wants to say that means the Earth can't be 4.5 billion years, they have to marshal a better case than what they have, because they haven't shown that it doesn't work. Question from Maria. It says, since God created the Earth to be habitable, what is our role in addressing global warming concerns? Is it possible that our human actions can cause the world to become uninhabitable, or will God override any human sin and error to a certain extent until his prophecies are fulfilled, predestined to exist? So I think this is a great question, Maria, and I appreciate this, because what I find are kind of two errors. And again, as I think and look at theologically, what has Scripture told us about this? One is we know that God's purposes are not going to be thwarted. that he is sovereign and he's in control and he's going to work out his purposes. But God has also given humans stewardship over the planet. And we can make two errors with that. One is we can say, you know what, God's plans are going to be sovereign. We don't have to worry. We can kind of do whatever we want and he's going to work it out. That minimizes or does not take properly into account the fact that he's given us care over creation and he's going to hold us accountable to that. The other side is to say, okay, we can affect creation. We can actually do things to destroy what's going on out there. And again, I think that's a problematic place because it kind of leads to creation worship if you're not careful, but it also neglects the fact that God is in control. And you know, the reality of it is we have been industrial for about the last 150 years. And I know there are a number of people who've done some abusive things, but there's a very real sense where we've just been growing in our technology, learning new things and trying to utilize those, in the vast majority of cases, trying to use those to help people and make life better here on Earth. It seems a little ridiculous that we could destroy the planet unintentionally by trying to go and do good. And so, as I've thought about this, it seems to me the position that takes both God's sovereignty and human responsibility into account is to recognize that God's fashioned this planet for a purpose. He's given us authority to rule over it and to subdue it, that we need to do that. And everything, and the guideposts that help us do that is that what we're doing should benefit both humanity and the planet. And so if we're proposing a solution to global warming that is detrimental to humanity, we're probably off. But if we're doing things to try and take care of humanity that are detrimental to the planet, we're probably also off there. And so really, I'm more concerned about how do we have a discussion where we're taking care of people and the planet so that we avoid doing what we want and saying, well, God's just going to sort it all out, or thinking that we're so powerful that we're in control of what's going on. Both of those are the two errors. I think God's designed things so that we live in the middle where we're taking care of the people and taking care of the planet. And that is a difficult thing, especially as we become more technologically advanced. Question from Peter says, Jeff, what do you think about Lee Smolin's theory of cosmic natural selection? Does that address the fine-tuning problem? So just a little bit of background. Lee Smolin's cosmic natural selection. Basically, there's a number of details, but the idea behind it is that where black holes form, there are new universes being formed. And so there's kind of this natural selection process where universes that generate lots of black holes produce lots of new universes that have universes that look similar to the parent universe, and universes that don't produce a lot of black holes eventually just kind of die off. And so that's kind of the cosmic natural selection. And so it's an interesting way of saying, okay, it has a couple of features. One is that universes that host life need to be universes that host lots of black holes as well. But also, it is predicated on the idea that universes or where black holes form, they produce new universes. Now, what Smolin has done is said, all right, what could I do to make this model testable? And he said, all right, if this model is testable, there cannot be neutron stars larger than a certain mass. And so we can actually go out and look. And if we find neutron stars above a certain mass, it's right around 2 times the mass of the sun, then that would show that this model is incorrect and in need of revision. So I think it's an interesting model that's out there on the table. But I would put that in the class of, there's a whole lot of models that are on the table that we just don't have the data that allow us to know whether they're right or wrong. So he's advancing an idea that I think will help us continue pushing the scientific enterprise further along. But I feel no need at this point to say that, all right, that's the model that's correct. And it still remains to be seen that just because black holes are produced, do they actually produce other universes? The challenge in verifying that aspect is that we will never be able to witness one of these other universes. And there was a paper by George Ellis that made an interesting comment when we're talking about the multiverse. Because I think the multiverse idea is a well-founded, scientifically well-motivated idea. And I think we could actually even find evidence that would tell us that a multiverse actually exists. With that background or basis, what Ellis was pointing out is that even if the multiverse exists, you have to be very careful, because you can't actually measure what's going on out there in the multiverse. And so what you say is going on out here is going to influence the predictions you make here. But we have no way of knowing what's going on out there. So if you say there's this vast multiverse that explains all the fine tuning, then obviously your model's going to do that. But we can't ever actually test whether that attribute of the multiverse is correct. And so we need to be careful that we don't just say, well, the multiverse produces this and it explains all the fine tuning. I can produce multiverse models which have all the fine tuning we see in this universe. And right now we have absolutely no data that weighs in on which of those models is correct. So they're both equally good explanations. And so to say that, oh, I've got a multiverse that explains all the fine tuning we can see is an appeal to a future scientific discovery that may not actually come out, may not actually turn out the way the proposer wants it to be. Question from Stephen. It says, how can we truly know how old things are when time is relative to speed? And so I think if I understand Stephen's question correctly, is we're dealing with the fact that time, we tend to think of space being this quantity and time being this independent quantity that just kind of operate. And what Einstein, as he developed his theory of relativity, showed, and others have shown, is that space and time are actually far more complicated and intertwined than that. In fact, to properly describe the universe, when you're looking at general relativity, it talks about this quantity called space-time. And it has these kind of interesting features that the faster I move through space, the slower I move through time. And the faster I move through space, the shorter things, or the shorter I appear to people, and more massive. So there's these very interesting effects that show up with that. Now, so the question in that, or the relevant aspect of that is, does that relationship between speed and time, and actually it's gravitational fields in time as well, does that aspect of space-time change our ability to measure how old things are? And the short answer is not really, because the environments where, or for me to be moving fast enough that time has any sort of fun or really different, measurable difference, I have to be moving a fair fraction of the speed of light. So when we go out and actually do calculations of how old is this tree stump, or what's the radioactive decay going on here, we're doing that in the context of, we can just use general relativity, or not, we don't have to use general relativity, we can use Newtonian dynamics for that, because the densities are small enough and the times, or the speeds are slow enough that that's what applies. So even though space and time are tied together ultimately in the fabric of the universe, that doesn't really affect our capacity to do a lot of the measurements we do in time, because we're looking at radioactive dating, or we're looking at stars that are moving at rather ordinary speeds to measure their spectra in terms of measuring their quantity of elements or how fast they're moving away from us. And even where we know we have to take into account the relativist effects, we still get the same sort of coherent time scales that the origin of the universe was just about 14 billion years ago. Earth formed a little over 4.5 billion years ago. The moon was a couple 100 million years after that. Complex life showed up on Earth about 550 million years ago, and humanity arrived on the scene on the order of 100,000 years ago. Those time scales are unaffected by, or they already account for how space and time are interrelated, or they're largely unaffected by it. So yeah, we really do know the dates of things pretty consistently. Question from Leah says, how could an ancient meteor strike initiate subduction? And the basic idea behind that is that as an asteroid, if it's large enough as it comes in, typically it just hurts and it creates a crater here on the surface of the Earth. But if it's big enough, it can actually, the effects of that can penetrate deep enough into the crust, push things down. And so if you can imagine having two plates here, or plates that are on the Earth. And if something comes in and it hits it hard enough, hits this one, it can knock it down below, And if there's already a little bit of pressure there, it can start the process of subduction. And so if you've got these two plates, or just kind of the surface of the Earth kind of locked together in one plate, the asteroid strike could fragment the crust so that now you have plates that can move relative to one another, and it can separate them so that now you get the subduction. That's basically the idea there. So last question from Michael here. It says, does the Bible have actual miracles in it, or does only science apply? And I would say, one, to answer that question, we have to be careful we have to define what we mean by miracles. And a lot of times people mean miracles to be things that happen entirely unexplainable by the laws of physics. But when you look through scripture, you actually find the things that are attributed to divine activity where God's doing something miraculous. Often they have some aspect that's physically explainable. I'll give you an example. So if you're go back in Exodus, you've got the Israelites fleeing from the Egyptians. The Egyptians are chasing them. The Israelites are led back into the Red Sea, and they're surrounded by water. And so they're cornered. They can't flee. The Egyptian army's coming. And what you read now is scripture. God says to Moses, there's a strong wind that blew all night. And then the next day, the Israelites crossed on dry land. Now, why does the Bible include this strong wind blowing all night if it isn't relevant to the story? And if you go look at, there are articles out in scientific journals that show that if you have a particular configuration of land and water, so you have a lake with a large river that's 6 to 8 feet deep flowing into it, right at the conjunction, and you have a strong wind blow on that 30, 40, or 40, 50, 60 miles an hour for a sustained period of time, you're going to get a 3 to 4 mile swath of dry land for 8 to 10 hours. Now, if that's what goes on there if that's what's going on in Exodus, what you see is that you've got this process that I can explain with physical mechanism, or that I can explain using my scientific studies, but it's miraculous because it's what the Israelites needed at the right time, at the right place to effect their escape from the Egyptians. So miracles can be beyond the laws of physics, but I also think there are miraculous things that are explainable within the laws of physics, but nonetheless, they accomplish a purpose beyond that clearly has an intent and a purpose. And so, you got the supernatural beyond the laws of physics miracles. You've got these kind of hypernatural miracles where they're explainable, but nonetheless, I would consider them miraculous. And so there's a question as you look through a lot of scripture, which of these places where God does something miraculous, which of them are beyond the laws of physics, and which of them are maybe explainable in part by the laws of physics? And so you could ask the question of the feeding of the 5,000, or Jesus walking on water, or any of these other sorts of things that would help you understand, that might give us insight into what the miraculous nature is. And so I think it's a great question, and I would encourage you to go kind of dig into your Bible, and that will help you, or kind of dig in and see, and ask the question, what of these might we be able to explain? That doesn't remove that God's working there. It just means that we get a bigger picture, more insight into what he actually did in accomplishing his purpose. I thank you guys for joining us today. I want to encourage you to click on the link down in the description. You'll get you'll be able to download some slides. You'll get some more information. We'll get some contact from you just to establish a better relationship with you. Again, go down into the link down in the description. Thank you for your time here. And I just want to encourage you to, as you go out and look at creation, to remember God's awesome power, that everything we see, we may be able to understand it, but he's the one who's in control of it all. And we see evidence of design in creation. Remember that, and that should point us to worship the Creator, and remember that he's got a plan, and you are a part of that plan. So again, look down in the description, click on the link, get some slides. Thanks for joining us today, and have a great evening and afternoon.